So our first vocabulary word for today is polynomial. So a polynomial consists of constants and variables that are joined together by addition, subtraction, multiplication. Constants and variables are grouped together into one or more terms, and these terms can be a single number, a single variable, or a product of numbers and or variables with exponents that are non-negative integers. So some examples would be 3x squared plus 4x. That is one example of a polynomial. You've got some numbers in there. You got your 3 and your 4, and you got that exponent of 2, and you got some variables in there. Another example would be 5y to the positive 3. That's another example of a polynomial. That's just a one-term polynomial versus my first example, which was 2 terms. You could have just a single letter. If I just said z, that's a polynomial. You could have single numbers. So like 4, that's another example of a polynomial. So basically everything you've been doing so far is a polynomial. We just haven't used that term yet. So within our polynomials, we have to do what's known as standard form. Standard form contains no like terms. If there were any like terms, you would have to combine those first. And exponents are written in order from greatest to least. So this one right here is in standard form because it goes to 3x squared and then the 4x afterwards. So my largest exponent is first and then my next largest, and it would keep on going down the line that way. A degree, the degree of a term is the total of the exponents. The degree of a polynomial is the highest degree of its terms, which I realize that doesn't make much sense right now, but as we go through our examples, it will make more sense, I promise. And then our leading coefficient is the coefficient of the first term of your polynomial. It's pretty self-explanatory. Leading coefficient, it's the one that goes first. So let's take a look at our table down here. So we're going to start off with the polynomial of 4. If I were to write it in standard form, it would still be 4. Doesn't really change it much. Are there any variables with my 4? No, it's just the number 4. So that means this is a degree of 0 because there aren't any letters. That's how I know it's a degree of 0. By degree, this is what we call a constant. It's always going to be 4. It's never going to be anything other than 4. That's why it's constant. It's always the same. By number of terms, this is one term. It's just the number 4. We call one term a monomial. And because it's just a constant number, there is no leading coefficient for that. So our next one, we have 9 minus 8x. My x has to go first. So it would become negative 8x. That minus sign stays with my 8. And then it would be plus 9. Now it's in standard form. Letters always have to come before any numbers. So letters always before your constants. So now if I look at my x, what is my exponent on this x? It'd be a 1. We don't always write those ones, but it is an exponent of 1, which makes this a first degree polynomial. Whatever that largest exponent is your degree. A first degree is what we call a linear. We have done a lot of work with linear. We found the slope, we find the rate of change, we've graphed them, we've answered word problems with them, we've graphed 2 of them, see where they cross. We've done a lot of stuff with linears. This has 2 terms. It's got the negative 8x as one term, and then the 9 is a second term. So we got 2 terms here, which would make this a binomial. And then our leading coefficient would be that negative 8. So that first term is the negative 8x. The coefficient part of that is the negative 8. So our next one, largest exponent always needs to go first for our standard form. So that means this 7x squared needs to come first. And then the 5x would come after it. That's our standard form, largest exponent first. So now once that we have the largest exponent first, that tells us our degree. This would be a second degree polynomial. We call these ones quadratics. We've done a little bit with quadratics so far. We've graphed them, stated when they're increasing, decreasing, when are they positive and negative, and domain and range. We've done all that stuff with our quadratics so far. This is still two terms, so that's also a binomial. And what would our leading coefficient be? 7. So if we look at our next one, which term should be going first? The 4x to the third. And then our 8x. Largest exponent is first, and then the next largest after that. So what degree would this one be? Third. So we call a third degree polynomial a cubic. How many terms do we have? 2, so that makes it a what? Binomial. And our leading coefficient would be 4. So then our last one in our table, which term should be going first? Very good. Negative 3x to the fourth. Which one should be going next? 2x to the third. And then our fourth. So we got it in standard form. What degree would this one be? Fourth. Which makes this a quartic. Fourth degree is what we call a quartic. So now beyond fourth degree, you guys don't really have to know, but they also don't really have any special names. If you got a fifth degree polynomial, they just call it a fifth degree polynomial. You got a 10th degree, they just call it a 10th degree polynomial. So there's no special names beyond the fourth degree. How many terms do we have? 3. So we'll call this one a trinomial this time with our 3 terms. And again, beyond trinomial, if you got 4 terms, they just call it a polynomial. You got 5 terms, they call it a polynomial. You got 11 terms, they call it a polynomial. The only special ones are your monomials, your binomials, and your trinomials. Beyond that, it's just a polynomial. And then our leading coefficient would be negative 3. So let's look down here to where we're identifying the different parts of the expression. You guys have done this before. Coefficient is our number out in front. So in our first example, our coefficient would be the 3. What would our coefficient be in number 2? Negative 5. What would our coefficient be in number 3? No, not 2. I tricked you. There's no coefficient. All right, so your base is whatever has the exponent attached to it. So our base in the first one would be x. Our base in the second one. And then in the third one, your base is the 2 because the 2 has the exponent on it. And so then our exponents, what is our exponent in the first one? 2. Second one? Last one? 3. So those are our different parts. So what we're going to be doing is we're going to be doing combining like terms. Like terms have equivalent variable parts. So that means it has the same letter and it has the same exponent on that letter. So for example, x squared y and 4x squared y. Those are like terms because they both have an x squared and they both have a y. If I try to switch it up and I say 7xy squared, is that the same as the other two? No, because this x is squared, this one is not. So those would not be like terms. But a lot of people look at it and they go, well, one of them's squared and the other one's not. But you got to look at the same letter, same exponent. So let's take a look at some examples on the back. We are going to be deciding if these are like terms or unlike terms. Let's So we look at the first one, letter A, 3x squared and 4xx. Are those like terms? What if I rewrote this as the 4x squared since I have those two x's there? Are those like terms? Yeah. How about letter B? Are those like terms? Yes, they both have a cubed. How about C? No. D? Nope, because we got an x to the fourth and an x to the third. Those are not like terms. Those are unlike terms. How about E? Those are alike. Even those are in reverse order, they still have the same exponents on them, and they both have the same letters. They both have x, y in there. And then how about F? Like. So being able to tell if things are like terms or unlike terms is going to help us with our next two parts, the adding and subtracting of polynomials. So when you're adding and subtracting polynomials, there's a few different ways you can do it, and I'll show you the both different ways, and then you can decide which one you want to do. One way is to line up your like terms. So here we have polynomial number 1. They've put it in parentheses. They don't always put it in parentheses, but this example they have. And then over here we have polynomial number 2. Again, they use parentheses to separate them, but you don't have to. So what I like to do, one way to do it, and I'm a visual person, so it just helps me see it better, is I take my second one and I line everything up underneath my first one. So this x squared, I line it up under the x squared from my first polynomial. And then my 3x, I line up under the negative 5x because those would be like terms. They're both x to the first. And then my minus 7, I line up under my 1. So now we're going to go ahead and add them. And it's kind of like when we did our adding our radicals before. These are both x squared, so I'm going to add their numbers out in front. So there's a 1 here. We don't always write it, but it is there. So negative 2 plus 1 would give me a negative 1x squared. You just actually add and subtract those numbers in front. For the x's, we have negative 5 plus 3. So that would give me a negative 2x. No? But you're not multiplying, we're just adding them. By adding? No. Because one's squared, one's not. All right, and then our last one, 1 plus the negative 7 would give us negative 6. Now you don't have to write that negative 1 in front of our x squared. You could just write it as negative x minus 2x minus 6. Those are the same thing. So whichever way you prefer to write that. If you want to actually put the 1, you can, but you don't have to. All right, let's try the second one. So we got 8y squared plus 7, and then we're adding to it a 5y squared minus 2y, and then minus 3. So I showed you on the first one, one way to do it is to actually line up your like terms. So in this case, you would line up your y squares, your y's, and your numbers. Another way that some people like to do it is they go ahead and they circle the first one, find all of your y squares, and you circle them, and then you add them. So 8y squared plus 5y squared will give us 13y squared. So then the next term should be your y's, but we only have one of them. You got that negative 2y there, so that's going to stay as negative 2y. And then 7 minus 3 would give us a plus 4. And notice I used a different symbol for the different terms. So my y squares were all my circles. I underlined just my y's, and then I boxed in my numbers. That's another way you can do it. So whichever way you prefer, you are more than welcome to do that. The other little unwritten rule is you always have to put your answers in standard form. They're not always going to tell you to do that. You just have to remember you always got to put your answers in standard form. All right, so let's take a look at the next one. We are finding the sum of this polynomial and that polynomial. Ones like this, again, I'm more that visual person. I like to line them up. If you don't want to line them up, you can add them the other way. So there's my first polynomial, my negative 2x squared y plus 4x minus 9xy squared plus 3. So now I'm going to line up the other one underneath it. So plus 3x squared y. And then I got 12xy squared. So I got to line that up under my negative 9xy squared. Careful, they did switch that order on that second one. And then put my negative 2x under my 4x. And then my negative 5 underneath my 3. So now we can add them. Negative 2 plus 3 would give us 1x squared y. Or you could just write x squared y. You don't even have to put that 1 there. Same thing. And 4x minus 2x would give us a plus 2x. Negative 9 plus 12 would give us a positive 3xy squared. And then 3 minus 5 would give us negative 2. So that ends up being our final answer there. Four, they already lined up for us, which is very nice. So 9 plus a negative 5 would give us 4xy to the 6th. My negative 11x to the 4th y, does that have anything to combine with? Nope, so that's just going to stay exactly the way it is. I'm just going to bring that down. And then how about the x to the 4th y to the 4th? Nope. So we just bring that one down. That ends up being our final answer. So the application of perimeter, that is when we usually use adding our polynomials the most. What does it mean to find the perimeter of a shape? Add up all the sides. So with our rectangle, since this top is 9x minus 10, that means that bottom down there is also 9x minus 10. And since the left side is 5x plus 2, what is the right side? 5x plus 2. So now really the easiest way is just line them all up. I start at the top and I kind of go clockwise. So I put my 9x minus 10, and then my 5x plus 2, and then I get my bottom one, 9x minus 10, plus 5x plus 2. No, because of the x you cannot. So let's add these up. Negative 10 plus 2. What does that give us? Minus 10 more. Plus 2. Negative 16. So there's our numbers. Now we got to add our x's. 9 plus 5. Plus 9. Plus 5. So 28x minus 16. That would be our perimeter. That just gets into a skill that I haven't taught yet. You're going a couple of days ahead of me. I'm trying to stick with what I was teaching in the notes today. Okay. So number 6, we have the shape of a square. What's true about all those sides of the square? They're all the same. So we would just line these up 4 times. So then adding negative 2 plus negative 2 plus negative 2 plus negative 2. Negative 8y. 3 plus 3 plus 3 plus 3. 12x. There we go. So you got 2 more shapes on the top of the next page. I want you guys to try those ones on your own. Find those perimeter of those next 2 shapes. So hopefully your answers match mine. You should have 9x plus 18 for number 7, and then 15x plus 4 for your number 8. So then the last thing for our notes today is we're going to be doing subtracting of polynomials, which is actually very similar to addition. You just have one extra step you need to do. So if we look at example number 1, we have 5x minus and then parentheses 2 plus 2x. What you need to do with your subtraction is just anything in the parentheses after the subtraction sign, you need to change the sign of. So this would become negative, and then that one would also become negative. The subtraction sign changes those values. And so now it's just like the other addition problems we were doing. I would line up my x's. There's no number for my 2 to get combined with. So 5x minus 2x would give us 3x. And then, as I said, that 2 has nothing to combine with, so we just bring down our minus 2. And we're done. So if we take a look at the second one again, we got our subtraction sign in between the parentheses, so that means this 8 is going to turn to negative 8. That 4 is going to become a positive 4x, and I'm going to line up my like terms. So then 12x squared minus 8x squared would give us 4x squared. And then 7x plus 4x would give us 11x. Let's look at the next 2. So again, this is going to become negative, negative, negative. So all 3 of those after that subtraction sign in the parentheses are all going to change to negatives. Now my first polynomial doesn't have an x cubed in it, so I'm just going to put my negative x cubed kind of out in front to a little bit to the left of it. Then I'm going to line up my negative 6x squared and my minus x. Yeah. So this becomes a negative x cubed because that has no other x cubes to combine with, so that stays the way it is. Negative 3 minus 6 would give us negative 9x squared. And then what happens with our x's? Cancel. So that's our final answer for that one. Negative x cubed minus 9x squared. And I always put stars here on this one. Subtracted from. This is a concept they always ask on the Regents exam. And 75% of the time, everybody gets it wrong, and it makes me so angry. Subtracted from means the subtraction sign would be in front of the first polynomial, not the second one. It's like if I said, subtract 4 from 6. You guys would instantly tell me that it was 2, because you know how to do it with numbers. It's the same thing with your polynomials. If you're subtracting this one from that one, you've got to change the signs of the first one. So when I line these up, it becomes negative x squared plus 2x and then minus 1. You got to remember to change the signs of all of them. So 4x squared minus 1x squared would give us 3x squared. Negative 3x plus 2x. And then negative 5 minus 1. Negative 6. And then 5, it's the same thing. They're just writing it in a different way. So they tell us that A is this polynomial 4x squared minus 2x plus 3. And then they tell us B is this polynomial, oops, forgot my 1, negative x squared plus 5x minus 1. They want us to find the value of A minus B. So A minus B. So that means I'm going to replace a with the polynomial that they told me it is. They told me it's 4x squared minus 2x plus 3. And then I'm going to subtract from it my b, which is the polynomial negative x squared plus 5x minus 1, bless you. So we're still doing a minus b, we're just plugging those polynomials in for a and b. So now we're going to follow the same subtraction rules. I'm going to change my sign, so that's positive, that's negative, that's positive. Then I'm going to line up my like terms. So 4x squared plus 1x squared, 5x squared. Negative 2x minus 5x, and then 3 plus 1, 4. And there we go.